Now we're going to learn some other expressions today that will make it a little more pretty. I'm going to show you another command too. So that would be a way of listing all of those that have extensions. This also lists all the other things here. We're going to talk later about grep to drop off stuff I don't want.
I don't have VMware on my computer.
Okay.
So should I just move to a different one, or?
There's no VMware player loaded on that computer. Yeah. Yeah, that'd be great. And I'll write down the number and we'll get that on.
Okay.
That means someone has deleted it or removed it.
Ain't that fun?
Yeah. Sorry. That happens. Okay. So I could just do that. That's good enough for this. All these files have, these are directories that have an extension. Right at the beginning, it's going to list all the files that have an extension. So if I go up to the very top of this, there's all my files with the extension. So right here at the top, these are all of my files that have extensions, or that have a period and a dot extension. So I could just do a quick screen capture of this. Actually grab this screen clipping tool. Add it to the quick access toolbar. I just right clicked on the screenshot tool itself and it allowed me to add it up here. And then I just click, grab my screen clipping, and what if I just wanted the 3-letter extension? Did I do the same again? Yes. Yes, I just used the question mark. And then it will only match anything that has all 3. And so in this case, it just matches 3 files. So I get .net, .gen, .cfg. Because none of the directories have just 3-letter extensions that happen to appear in my EPC directory. So I get my 3-letter extension, click on my little tool, come back, tool, grab my 3-letter extensions, and okay, what if I just wanted file names that contain uppercase letters? Now there's multiple ways of doing that. One is the way that they're showing. So let's do it the way that it was showed here, which is using this extension. I'll just copy this. It says no such file or directory. So I need to find something that isn't just an uppercase letter, but that has an uppercase letter with 0 or more characters before it and 0 or more characters after it, and then away I go. And I get all those that are uppercase. Again, I'm getting all the directories listed down below, so I'm going to scroll up. I'll show you how to throw those directories away. But as I look through the files, these are all my files. Am I finding more? Well, there's my uppercase letter. A little too far. Let's start out with I'm going to have to show you the other because it's going to make life a lot easier. It will drop off these other files so I don't have those variable from the screen. Notice that these are the directories that also have uppercase letters. So it expanded, picked up those directories, and I'm getting all the files listed in those directories. Let's take off the -L to show you what is happening. And I'm going to show you how to drop out things that are not files. This has gone through, all these directories had uppercase. So, maybe I didn't want all those listed. Should I switch from using the ls command to the echo command? Then it won't go down into those subdirectories. So let's try the echo command. And then, what do I get? I get a listing, but it also, these may be directories, but I get everything that has uppercase letters in it. Some of those are files and some of those are directories, but everything that's there has an uppercase letter. So, that's kind of what it was asking. I go ahead and do this. Now I'm going to show you a little better way how to get these more precisely by using regular expressions. So let's try this for just to answer the question. Can you list files whose name is 4 characters long? Again, we'll do the same thing, only let's do echo and then do 4 characters long. All of those files or directories are 4 characters long. So it's listed all the 4 character long ones. Actually, of that group, only one is an actual file. All the rest are directories, but we'll leave it at that. So again, I took a stick in and took my tool. Okay. Now, what if I wanted to do this a little bit better? It's kind of sloppy listing directories and other things in there. I want to be able to cut and manipulate things, find things, drop off things that I don't want found, and do some other. So let's say if I wanted to do this a little better. Let's go back to this list file names with 4 characters long. Multiples of ways of doing this. To make it easier, because a lot of people were asking me, you do it so fast on the screen, I come and try it and I can't remember where it is, so I put some notes together under files. And hopefully make it easier for people to get at. So if we look under bash scripting, under files, I've added a few. Okay, let's go under tutorial. There we go. So I've got some notes that I put in tutorial. And I've just copied some, ways of getting 4 character files. So let me show you this first one, or I'll show you this last one first. So if we grab this one, and let me talk about how it works. So this is how a programmer would do it because they want a little more precise than what we're getting here with the echo. Let's do this in pieces. Well, we'll do the whole thing in little pieces. How's that? Control-Shift-V or paste. So this actually gives me files, MOTD and RMT star, that are the 4 character files. So this actually gives me the 4 character files that are in that directory. So before, did I get RMT? Notice RMT got dropped out because RMT had a special character in it that made it so it dropped out of the search. So that file got dropped out. So let's go over this a piece at a time. If I do ls-f, it means flag the files. So all the directories, and notice all the ones in blue, have a little flag after them to indicate their directories. So this is a good way of splitting the directories from the files, which is what we're going to do with the rest of the command. As I put in the rest of the command, I use grep. Grep just means find. So it's going to search in there, and I'll take off the rest of this so we can see where it finds. So it says grep, and -v means inverted, or means don't look for anything that doesn't have this. So if it doesn't have the little slash indicating it's a directory, then it must be a file. So this will give me the listing of just the files.
What was the V again?
V is invert.
For Victor?
V for Victor.
Yeah,
V
what's
for
the V?
V is invert. It means look for everything that doesn't have this. If you want just the directories, try it both ways. If I take off the V, what's it going to find? It's going to grep through and it's going to find the directories. So now I have a listing of all the directories. I wanted a listing of files, so I wanted everything that's not marked as a directory. So I do that with the V. This gives me an entire listing of files. So now that I have a listing of files, I'm going to hunt through those files, and I'm going to look for those that have 4 characters. grep uses regular expressions rather than wildcards, but characters, the little hat character means start at the very beginning of the line, and then the ... indicates I'm looking for 4 characters of any kind. I can have them stars, any special characters, and then ending with a $sign means that it needs to end there. So it's anchored on both sides. Those are called anchors. Yes.
What does grep do again?
grep is a searching command. It'll search through and give you back the search results. It'll also look inside files and search inside them.
And egrep?
egrep is an extended version of grep that gives you the extended searching set. Which is probably not going to mean anything to you yet.
No.
You can use either one. Either one will get you the same results with this. egrep, they had grep and they wanted to extend it to make it so it had more special characters that you stuck inside it to make it search through things. It's the extended regular expressions that it added.
The $sign is the value. Is it finding the value? Or?
No.
It's ending back.
This just means end. $sign in regular expressions means end. So it wants the very end of the line should be that last character. And the very beginning of the line, so it should have 4 characters on that line. That's what I'm looking for. Okay, so that's a way of doing it. That gives you more precisely, these are the 2 files, they're not directories, that are in there that are 4 characters long. So I can get, using grep and using some of the other commands, I can get it more precise. I've gone through and given you a couple of other examples, if you look at those notes. One is using the find command. This is kind of nice in that it does a standard find.
Well, how's it different from grep then?
Okay. grep is a search command that will search inside of files, and find is a command that looks inside the. It's how they do it on the inside. They're very similar, and you can do them to do similar again. Simplify. Very similar. They'll do it the same way as, except one uses regular expressions and one uses brace expansion.
So when we'll use the grep, do we have to use divide? Divide?
Yes, that's a good way of looking at it. When you use the grep, you need to use a pipe, and when you use the find command, you don't have to use a pipe. How's that? At least gives you the. That at least gives you a difference between the 2.
How does that stream?
So, if I'm using the find command here, let's illustrate it. Let's just use, if I just use the plain find command, what's find going to find? It's going to find everything that's inside the current directory that I'm at, everything that's underneath it, and every file that's from there on down. Does the whole tree.
All the files.
All the files that are from the point you're starting at, the dot, all the way on down to every file that's underneath it. So it finds you the entire tree underneath where you are. Is that what I want to find? No. So I start limiting my find. I do a dash max depth. That means just find on the first top level. So if I do max depth 1, I'm just going to find things at the top level. So if I press enter on this, it's going to find everything in that directory that's in my current directory, and then all the files in it. So it found all of the files in that directory, and all of the directories in that directory. So it found both files and directories. So to eliminate the directories, I say find files. So I'm looking through, and the type I'm looking for, type is F for files. So I'm finding files. So now it goes through and finds all the files. So now that it's found all the files, what would I like it to do? Well, I would like it to find all the files with a file name that's 4 characters long. So 4 characters long will match a name. They're named with 4 characters. 1, 2, 3, 4. That'll match the ones with 4 characters. Notice that I lose my RM star because it's a special character and it drops out of the search.
So why are you doing question marks instead of periods?
Okay, that's a good question. It's because this command explores wildcard expansion, unless I tell it to use regular expressions. It can do both, actually, with find command, but we won't go there yet. Right now it's doing plain wildcard expansion. And so I don't use the periods. The periods are part of what is called a regular expression. And I'm introducing them both at the same time, which is probably confusing. But having them both gives you more flexibility. So there was a group that said we're going to do things with wildcards. They were handling the LS. And as true of Linux, there's another group that's saying things from a different perspective, saying, you know, a lot of what we're doing as system administrators is looking through a file and changing particular things, or moving things around. And so they created different functions like sed and awk and grep that are hunting through files and manipulating files on the inside. Now those tools, because everything is stored as a file, all the directory management is stored as a file, and you can search through that too. So greps can search through the file management system as well as looking inside the files. So hopefully that helped a little, or maybe even more confusing. So we can go through and find the files that way. Another way we could find the files is using a whole group of these commands. We'll go over one more and then we'll call it done for this assignment today. Let's do this one in parts. So the first, what does ls-l do? What's going to come up? Yeah, so I get a listing of the etc directory with permissions. Notice that directories are marked with a D in this column and files are marked with a dash in this column. Could I use that to separate them out between files and directories? Yeah, so that's the first thing I'm going to do is use that to separate them out. So I'm going to look for something, and again, regular expressions, the caret is start, that start with a dash. So look for only those that start with a dash. Is that going to find me just files? Okay, so I've got rid of all the directories with my first grep. Okay, now we're going to do another command. The awk command. Awk command is a good command for parsing things. It's a parsing command language. It's useful for chopping things into bits. We're also going to learn cut commands and some of the others show, but awk command. And so I'm going to use, and awk command splits it into columns. And typically it'll use spaces. So if I don't tell it what to use as a delimiter, it will use spaces, and multiple spaces count as the same for a column. So if we look at the ls-l, you'll notice that there's spaces in there. There's sometimes more spaces, but there's always spaces in between each column. And so if I count over 9 columns, I will find the file name. So what this awk command does is it chops out the other pieces that I want and just prints out the file name. So now I have just files. So these are all the file names that are pulled out by pulling out column 9. Nothing's up this sleeve, nothing's up that sleeve. And you have this, so you have this whole command copied into the notes. So you just pull it out in those tutorial notes, and you have the whole command. So
The
you don't have
columns
to
would
copy
be
this.
the columns would be the permissions, the user. The
Yeah,
date,
so let's count the columns.
okay.
This is column 1, 2, 3, 4, 5, 6, 7, 8, 9. This is column 9. Could I have any of these other columns? Let's say I just wanted the permissions. I could have that. I want just the groups. I could have that.
Would you be able to pull like the permissions and 9?
Yes, I could do that. Just put a comma in between the two. So I can pull 2 columns out. So yeah, it gives you a lot of flexibility. awk is a very useful command. Okay, so going back to this, so I'm going to print 9. Now I want to search through those with my, now that I have a listing of files, search those through with my grep command, and I will have what I wanted at the beginning. So I'm looking for those that are that start, that are 4 characters long, and then end. So start, 4 characters long, and end, and sure enough. Now notice I also lost the start character doing it this way. So is this as accurate as the other one? Well, it depends. Sometimes you want to lose the special file names, and sometimes you don't. So it's depends on what you're trying to get. So far the one that's been the most accurate has been this one, where I mark the directories, drop them out, and then I look for my pattern. Because this one will also find my special ones that have special characters in them. They don't get dropped out. Which command dropped out those special characters? The awk command. Didn't know how to respond to the special character. So I dropped it out. Okay. So that would be a more extensive way of doing it, because a lot of people were asking me, well, it didn't look very good. How do I make it look good? This would be ways that you could make it look good. In terms of actually completing the assignment, just using the echo command would be just fine. So this would complete the assignment. For those of you who want the actual precise answers, that last one gives you the most precise answer, which would be go mark them in some way, drop off the directories, and then look for what you want from the neighborhood expression. Okay, enough of that review. Let's review some bash script. Unless people have, does anyone have more questions that they want?
Was that
answered
1
now?
through 8 that we
That
just
was,
did?
we just did 7.
7?
Uh-huh. So it was in that 1 through 8 group, and it was 7.
Number 7.
We're going to go over little bits of them each time rather than going over all of them at once.
Thank you.
That was overwhelming people. So we'll try it this way. Okay. So let's say we create a loop. If I type in, actually, let me go a little bit bigger text. I'll drop things off screen, but we can go. So if I put for I in 1, 2, 3. Okay, so I'm saying for something in something. Maybe I'll come back and get those. What if I did for my file in star? So if I list star, it's going to list through all those files in the directory, right? And I'm just going to echo out. Let me do a do. Okay, so that went and listed through all the files and directories in that directory.
How
Yes.
did you get out of that?
Oh. How did I get out? I put in both a do and a done. So if you put 4, it knows that I need a start of the loop with a do, and it's looking for an end of the loop with a done. So let's go back. So if I just type for my file, let's do it for I in 1, 2, 3. Let's try it this way. Okay, then I press enter, and it gives me a little bracket saying, I know you haven't finished the command, because if you have a for command, I need to find a do and a done command. So I enter in the do command, do, and then maybe I could say echo, this is loop, iteration, I. And then be done. So I need a do. If I have a for, I need to put the loop inside a do and a done. So this will go through and count through. This is loop iteration 1. So it does it for 1, does it for 2, does it for 3. Now could I have it in any order? Yeah. So if I wanted it, instead of doing 1, 2, 3, could I do it 7, 9, 3? Yeah. And we'll do 7, 9, 3.
What was the one I was
Oh, the $i says look for the variable I. So it goes out and says, do I have a variable I? The variable I was created for I, so that created the variable I. And then this is the set it is in, it's some countable set.
Okay, so I would equal 1, 2, or 3.
Yeah.
Because you.
And that first time, and then I typed in 7, 9, and 3. So I is 7, 9, and
And
3.
then it's just gonna, since you put echo, it's gonna echo that plus I, which is 1, 2, 3.
Mm-hmm. Yeah. Now I could make this, you know, it doesn't, it can be anything that's countable. And the computer, it counts with everything. It can count with letters too. So let's say I wanted to count, you know, A through X, for example. Then I have iteration A, iteration C. I did too many letters because it went off the screen. Sorry about that. Let's do A through H. A, B, C, D, E, F, H. So anything that's countable, I can stick in the in statement. Another way I could do it, it'd be to do it, maybe I want it to count from 1 to 10. So I want it to count from 1 to 10, the way it goes, and it counts from 1 to 10. Let's say I wanted to count it from 10 to 1.
And are those things stored somewhere?
Stored
Do
somewhere.
they like become like a file?
Yes, I could save these as a text file and run this as part of my bash script. Where you're going is very good. Now I want to be able to save this command so I can run it a lot of times. It's obviously saved in my history. That's why I'm able to hit the up arrow and just change the one to the other and change it. So 4 is quite a powerful loop. 4 counts through anything. A, B, C, D, Z through A through I, all the ones in the files in this group, all of the ones that are 4 files long. So to get back to our thing that we were doing before, so if I wanted to list out every directory and every file that had I could do every one that was let's say I wanted to do my 4 question marks. What's 4 question marks going to find? Any file or directory that has 4 characters in it. So what's this going to do? Now, getting back to your question, what happens if I'm stuck in here? I didn't want to do the command, I just want to end and get back out. How do I kill something that's running in bash?
Echo.
Hmm?
Echo.
Control C is one of the best killers. Control C will kill it. If I just want to temporarily, let's leave it there. Does that answer that question? So if you get stuck in anything, you can hit Control C. If you want to just stop it, you can hit Control Z, and that halts it and gives it a pause. And so if you want to just pause it, then you can hit Control Z. Go to sleep. Tell it to go to sleep. So it just takes the process of moving.
This is anything, right? If you're stuck
So if you're stuck anywhere, let's say I'm stuck in VI. So if I type VI and I can't remember how to get out of VI, what could I hit? Control C, and it should get me out. It doesn't quite get me out because it's capturing. VI wasn't a good example. You do have to figure out the Q key to finally get you out. Or Control Z, if you want to save it. But most anything else that is required. We'll go more over processes. We'll talk more about that. Okay, so we've got the for loop. Now, the until loop, very similar to the for loop, but the until loop does it until a condition is reached. So, until, this sort of thing happens, do this and be done. So until answer is green, what is your favorite color, and read the answer. So I could just take this loop. I've got it somewhere in a text file, to make my life easier. There we go. So I'm just going to copy this text. You can just copy it out of the slide. Maybe.
Where is this at? Is this in the files?
Yeah. If you look under files, that's a good question. Very good question. We haven't shown that very well. If you look under files, and then you look under what today's topic is, which is scripting, chapter 2 scripting, you'll notice that it has bash scripting. And that's where I'm getting this from. This is my PowerPoint presentation. Bash scripting. So, and if you're in this mode, display mode, it doesn't allow you to copy and paste it. So if you just drop back out to here, then you can copy it and paste it. Okay, so I could have typed it, but until answer is equal to green, it's going to do. So what is your favorite color? So I can enter in whatever my favorite color, red. It's just going to ask me what is my favorite color, blue. I can enter in blah blah blah. I can enter in 1, 2. I can enter in 3, 4, and it's just going to keep asking me until I type in.
Is that case sensitive?
Okay, let's see. And the answer is he already answered it, but we'll do it anyway just to show.
Could you make it accept both upper and lower?
Yes. Ooh, excellent thing. Yes. So this is an exact match. If I use the equal sign, I get an exact match. Yes.
If I did something slightly wrong, I put that in and it just endlessly continues to spit out what is your favorite color.
Yes. So how do you get out of it?
Control C.
You can, Control C will get you out of it. Or what if I type in the magic word?
It doesn't let me type anything. It literally just.
Oh, it literally is just scrolling on the screen?
Yeah.
Okay. You left off read, answer. You've just got echo on there. So it's echoing, you're not reading. Okay, so let's try this again, just typing each part out. So if until, and we'll go ahead and do answer. So I'm using the square bracket to do the test the condition. And let's choose another color. So until answer equals red, we're going to do this loop. And I'm going to do it my sloppy way. I don't know if it's a sloppy way, it's the way I normally do it. Okay, so I'm giving it a prompt with a dash P. I can give it a prompt, and then I give it a variable answer. And type in that. So it asks me what my favorite color is, and I can enter green, blue, black. Okay, I'll come see why it didn't work. What did that work? Missing what? Oh, it's missing the end bracket. You needed a space after that. Put a space on both sides in the loop. Now it's reading in the curve. So even though it was missing a bracket, it kind of figured out where the bracket should be. So the problem is still running. So if you type in red, you'll exit out. Oh no, it's actually trying to execute the red because it doesn't have. Oh, that's kind of fun. Now, if you really get stuck inside this and can't get out, can you always just kill the terminal and bring up another terminal?
Yeah.
Yeah. So there's another option. If you really get stuck. Okay, so what is your favorite color? And I type in red, and sure enough, it lets me out. So it just keeps inside that loop until that condition is met. Yes.
And what does the dash P do?
Dash P allows you to put a prompt. So that's like saying, do a read with an echo. So dash P gives you a prompt, which echoes that out to the screen.
I just did that. Just I tried something else, so I can see why. I tried to see if I could
That would have been fine, but we needed to put a space after this, so we know this was a separate command. It's parsing on spaces. Several of you have done something that is worth noting. Let me show that. What happens if I don't stick this space after the read command? What's going to happen? Again, this parses based on spaces, so it won't receive this test command. This is the test command. This is the start, and this is the end of the test command, so it needs a space to know that that's the end. If I put no spaces in, it'll think this bracket as part of what it's looking for with this answer symbol. So, it won't work. So those of you who have not put the space in have discovered that this doesn't work. Or shouldn't work. Won't work well even if it does. Now, it'll give me a warning. It says, I found one of these, but I was missing the end one. It couldn't find the end one. Can't find it, usually it means you haven't got a space so it can hunt through and find it because it's parsing based on spaces. So it's asking me my color, and even if I enter in the correct answer red, it says, I'm still missing the thing. So every time it's going to say, I found this one, because it's checking this until statement, but I couldn't find the end of the test, so I don't even know what to test. So I'm giving you an error message back, and it will keep you in a perpetual loop because this condition will never go true, 0, and so you'll never get out. So you're stuck in an endless loop. So several of you have tried that. How do I get out? Control C. And I'm out. Okay. Excellent. Now we're going to go more over the test. Okay, now there's multiple ways of doing test. You used to type out test, T-E-S-T, and people got lazier and said, you know, I don't want to type that whole thing. I just want to kind of have something at the beginning and the end, so let's use square brackets. And so they map square bracket into test. And so typically you'll do the square bracket space, some sort of test condition, space, and the end bracket is the typical way you do test. It's a program that performs comparison, and a while statement is actually calls the test program to evaluate the condition. And you can see all the different comparisons that you can do by just doing a man page on test. And string comparisons, remember, they are case sensitive unless I turn that off, which I can turn off too. So how do I find more information? Well, if I just type in man test, it'll give me the man pages for test. So it'll give me things. If I use the not in front, it's going to check if it's false. I can also put my expression inside of parentheses if I want, and it'll give it true. I can do -A gives me the and, -O gives me an or, -N gives me the length of the string being not 0, -Z. We can do the standard equals, means the strings are equal. Not equal, the strings are not equal. I can compare integers using the -EQ. -GE for greater than. -GT greater than or equal to. -GT for greater than. -LE for less than. All sorts of goodies. I can have the same device in inode numbers. I can have the file modification date. I can do newer than, older than. I can do exist in the block special. I can do -F it's a file, -D it's a directory, -E exists, all sorts of good things. I've got all sorts of comparisons. The other nice thing about all of these man pages is they tell you who actually wrote the program. And so you can see who is the developer that worked on that code. I think that's kind of nice. And you can, how do you report bugs that it doesn't work? So Q quits me out of the man pages. I could also type help test. And it gives me the shorter version of this same thing. It gives me kind of the basic help for it. So it's got, I can do some sort of conditional expressions, I can do file expressions, I can do string operations, or I can do shell options, arithmetic binary operations, greater than, less than, equal to. And it says, go look at the man page if you want anything more. Okay, so that's the test expression that we're putting in. Now, also I want to know what is known as a conditional in programming. That just means I want to check the condition, and so I'll use something off then, if, then, else. There's a whole stack then, if, then, else. I can do if, then, I can do also an else if, then, I can do an else, and then I end ifs with the flipped around if, which is fi. So if starts it and fi ends it. Okay, too complex. Let's try out some simple examples. Several of you have asked also, if I'm not really understanding this bash stuff, are there some places I can go? Woolidge did a nice kind of wiki on bash that I like. I can send around that link in an announcement. I'll do that. In fact, I'll do that right now. So you'll have it. And what he's called is a bash guide. So I'll go ahead and send this link. Okay, anyway, so he's got a whole group that you can work through and get some additional help. If you look at his tests and conditionals, I think he does a good job of reviewing them, actually. I like his tests and conditionals. Okay. So, we'll do his example. If I ping out to something that is unknown, so it wants to be able to ping God, see if he's pingable. And I couldn't find the host, unknown host God. So that means that an error occurred inside my bash script. How do I look at that error? How do I, I've got an error printer on my screen, but how do I look and see if there's some sort of error code? Well, I can do it by echoing a particular variable. And the question mark is the way you get the exit code of that variable. So if I do echo question mark, it can tell me 2. Anything other than a 0 is an error.
Mine said 147.
Yeah, yours got 127 because it didn't have a host error, it had a different error. So are these error codes generally useful? No, they're not very useful, but you can use them to check did some sort of error occur. If it's not 0, some sort of error occurred. Now this last command was an echo. So if I do this again, do you think that last command echo worked okay? No problem? Sure enough. This command then executed worked okay, so if I echo it again, it's going to say yes. The last command executed worked just fine.
So this just checks the last command you put in the system.
Uh-huh.
Right?
Yes. This allows you to see what was the exit code of the last program, which is kind of nice. So now we can do an if. So let's do an if. We'll do if 1 is greater than 5. Then echo yes. And then if I just end my if statement here, what's going to happen? What happened? Nothing came out. Is 1 greater than 5? No. So if I bring up that statement again, and it's going to put in the little returns that it does those with. But 5 is greater than 1. So if I flip those around or made this a 10, what do I expect to come out? Yes, 10 is greater than 5. So it came out. Now, what if I wanted to say, I could give a more precise message. If 10 is greater than 5, then echo greater than. Else echo not greater than. So 10 is greater than 5. Change it around, and let's change these to variables. I make A greater than B. Okay, I haven't told it what A and B are. What's going to happen? No.
You take user input.
There we go. So I want the value that's in A and the value that's in B, correct? Then I could take some sort of user input. And I'm getting too many arguments. Do I get frustrated if I'm seeing error message, error message, error message? I could. Or I could say, hey, this gives me a chance to learn more about the command.
Just turn it off.
Just
Could you go and answer?
what?
Like if answer equals
Yeah, I could do it that way. What if I were to make these be expressly expanded before I stuck them into the grader? Kind of like I did with answer. Yes?
What do the quotation marks do?
They do the expansion. We'll learn more about that later. It's a very good question. So let's try them out. It's still saying integer expression. So what could I do at this point? What I'm trying to do is show a process. Because you're going to have a chance to do this when you write your number guessing game, which is your assignment going to be here in 3 weeks or something. End of the month. So you're going to write a game that you're actually going to guess numbers. So you're going to have to figure out, how do I do this? So how do I get further information about this? Let's say at this point I was feeling stuck. Ooh, good place. How would I get internet information on it? Okay, so I could type bash. And it's actually conditionals would be the magic word I would look for. But let's say I could start out with if and bash if statements, or integer if statements. And it'll give me examples of how I pull it up. So I can try out any of these examples. I can just copy and paste this code and try it out. And that kind of helps too. Other things that help. Sometimes it's in this case, actually, no. Yeah, in this case, yeah, I'll just show you. So if I say a equals 5, it was saying an integer expression. It didn't know what a was. A was a nothing, and nothing is not an integer, so it couldn't compare it with another integer. But if I say a equal 5, b equal 10, hit my history command, go back to it.
What's the history command? Is that
Not greater than. It's the up arrow.
Okay, okay.
Up arrow will go into the history. You just hit the up arrow, and it will get you there. So 5 is not greater than 10. True? Yeah, 5 is not greater than 10. How about if I say a equals 10? What do we expect it to give me? 10 is not greater than 10. 10 is equal to 10. Is that making a little more sense now? So I showed you how to get help, showed you a few of the conditionals, showed you if you go testing conditionals here, how to group statements. We're probably going to go over, we'll go over this a little more. Let's go over the conditional tests. So basically, there's different kind of patterns. We can do if, sort of command, then other commands, fi. You can do if commands, then. So how you put it together is your choice. Every bash scripter writes it a little bit differently. If you have other programming languages like C, they kind of tell you that this is what we want it to look like. With bash, it's the faster you can program, the better, because generally you're writing programs to fix something. You're going through someone, the server is down, the mails are not loading. That's because they have this bits in it, or this program has gotten into it, or this problem has gotten. So a lot of times you're writing very fast. There's some value into test it. Again, we already pointed out not having the spaces. You can do pattern matching. So this will go over kind of the stuff. Again, the tests will do all of these sort of things. There's a big giant listing. That's the same thing as if you had gone on the man pages, and you can find all of those things that you can test. Okay, let me show you another command statement that's kind of nice. This is really good for doing menus and for choosing through a group of options. So the way the case works is, case was originally set up to be very nice to go through making recipes and making things on machines is actually where it came out of. And so you would set it up, and so you could start anywhere. If you start, mixing the eggs, and then you can skip down, start from this step and then go through the rest. Well, to get out of that, you do what is a break, which is two semicolons gives you a break. So it'll do case, this variable, do this command, and then do break. If I don't stick in break, it'll follow its old method, which was go through everything. So it'll walk through the rest. So it'll jump to this one, case this, jump to this one, and then walk all the way through the rest.
So would that be kind of the equivalent of like in C#, just writing in breaks or something like that?
Yes, in C# you put in a break. We do the same thing. Yeah.
And it just takes it from a value too.
It just means it comes here, jump out to the end of case. Notice that, like if, you flip it around the other way and it becomes the end. So if has fi, case has case, and so you don't have to ever remember, am I getting the brackets right? Am I getting the little semicolons right? Those of you who have programmed in other languages, it becomes very important to do that. This one is a very flexible language.
That's very nice.
So you can use wildcard globe expressions. It stops matching when the first match is found, and then star will match everything. So it's kind of like the default or else or whatever you want to do position. So see if I've got a good example. I can quickly grab to this. And no, we'll just create that as we go. So we just enter in the case statement. And I'm just going to use A. So I start out my case statement, just put it in, and then I do an in command. It's important that I have a space in between here so it can break the variable. In command, and then I just do a value and then a parenthesis. Star. Okay, so if I set A equal to 5, what do we expect to have happen? 5 will come out. If I say A equals 7, what do I expect to come out? Please enter 5 or 10. So this is a good way of creating menus, jumping around that way. Last 3 minutes. That's pretty good. Got some things through. Maybe I will go over this. So it's a really good way of combining conditions. And is often used. So let me show you this. If I do and, that's an and function. So if I say if this one is true, then the other tricky thing about and, if the first one is false, does it matter if the next one is true?
No, they're false.
No. It's already false. So I don't have to evaluate the next one. The only time I have to evaluate the next one is if this one happened to be true. And so Bash is very smart in figuring, oh, well, if I've already got the answer, I can just skip to the end. So you can actually use that feature to say, if this one is true, then look at this one. So if this is true, then this one is evaluated. Otherwise, this one is not evaluated.
Just really quick, so what does it mean to put the $ in front of a string right there?
Okay, it's a good question. What does this $ do? If it didn't have the $ in front of it, what would it be? It'd be plain food. By putting the $ in front of it, it identifies food as a variable. So it says, go out and look in your variable table and find food. And whatever's stored in food, then compare that to the equals. So this one will only look at drink if food equals apples. Otherwise, it won't look at drink.
So why at the end of this we're putting FI and not
Okay, if anything that starts with if ends at FI. The do and the done is only for loops. So the for loop, the while loop, the until loop are all do done. So do and done are only used for loops. There's a reason in parsing for doing that, but it won't make sense to you, so I won't say it. Very good questions. Continue on working on the tutorials. Those of you that are still kind of getting those in, that would be great. If you want, let me explain just really quick. The next big assignment that will come in, if you look under assignments, it's going to be due in a few weeks, but it'll be actually your very first program that you will write. For some of you. For some of you, you've written programs in the past, but it'll be the first one you've written in Bash. So if I look on this, Bash, and we're going to study Bash Script Guessing Game is the next big one, and it's going to be due on January 28th. And if you click on it, it will give you, hopefully, no, give it to you. Oh, it looks like it's going to. Save this out. And we go let control. But this will give you, the instructions. What does it need to do? What is it called? Put the comments in. Keep track of the number of guesses, higher, lower, and then you just upload the script to Canvas when you're done. So those of you that are ahead can go ahead and jump right into it. We will see you next week. Practice with the Bash scripting quiz. You'll get a chance to do the e-case and the if statements, a few conditionals. Take that practice quiz so you feel comfortable with it. We'll see you next week. If you have any questions, feel free to catch me on Canvas. And I'll try to cover some of those in class if I get a lot of them. And otherwise, I'll just, message you back.